In the previous session, we had discussed about interfaces, where we basically try to understand that how we need to have a common communication protocol to help us to achieve a decoupled architecture. In this session, we will talk about abstract classes, and we will see that how we can use abstract classes to define reusable code in inheritance hierarchy. Basically, any programming language, any object-oriented programming language in the market today, like Java or C++ or C Sharp, basically has the abstract class fundamental in its framework. Abstract class helps us to define partial implementation in inheritance model. In the sense, it helps us to define reusable code in the inheritance model. Okay. For instance, that let's say that you have some kind of a logging utility. Okay, and this logging utility basically just writes something into a file. Okay, and it just basically writes into a file. It doesn't define the format of a file. Now what you can do is that basically you can inherit from this class, and you can say, okay, you can say that I need to write it as a CSV, or I need to write it as XML. So this is partial implementation. In the sense, it just writes to a file. It doesn't do anything more than that. It doesn't define the CSV or the XML format. But the child classes later inherit from this partial implementation and define the full implementation in their concrete classes. So you can say that when your project needs to define such kind of partial implementation in the inheritance hierarchy, in those instances you will need abstract classes. Let's take up a practical scenario here. We have a simple invoice project, and in this invoice project we have this DAL component, CLS invoice DB, and you can see that in the CLS invoice DB, whenever I do a insert or I do a update, etc., I always create this database object using the database factory.create database. So you can see that every method call I'm having this variable created or this activity done, which creates the database connection instance. Now, rather than having this redundant code in every method, what I can do is that I can make an abstract factory, okay, abstract class, I'm sorry, with some name like CLS invoice database, and define this reusable code at the parent level. Later I can inherit from the CLS invoice database and define my full implementation. So you can say that over here the CLS invoice database is a partial implementation. It doesn't know. Basically it's going to insert an invoice, it's going to delete an invoice, or probably it's going to get some products or something. Okay, what it only knows is that it needs to just create a database object. And because abstract classes define partial implementation, you cannot create object of abstract class. So the only scenario you will use abstract classes if you need to have reusable code or partial implementation code in the inheritance level, in the inheritance model, in the sense that if you need to increase reusability in inheritance model, you would like to have abstract classes. So this is all about abstract classes. The only point to remember here is that because there are two types of inheritance, two types of relationships which we discussed. Let's go to that. One is the aggregation composition, and one is the parent-child relationship. When you want to define reusability in the parent-child relationship, that is the inheritance model, then you need to define your partial implementation in the abstract classes. When you need to define reusability using aggregation and composition, then you don't need to use abstract class, because then the whole theory of aggregation and composition don't fall in the inheritance model, so the whole theory of your object model can become wrong, right? So if you think that the relationship has a relationship and you want to increase reusability, then you need to define that in a separate class. But if you think that you have some reusable code which you want to avoid, or you want to avoid the redundant code in the inheritance model, then you need to use parent-child relationship. So that's all about abstract classes. In the coming session we will discuss about the differences between interfaces and abstract classes.